have the front board again reorganized for you. I told you on Friday that you had a new survey out, survey number 3. It is due by Thursday, so please make sure you get that in. Do note I really read the responses and then go back and reread them. So if you give me something bogus, I will really give you a 0 out of 10 points. So make sure you seriously answer the questions. Don't just write something random. Next, if you look up there, on Wednesday after school is the next retake opportunity, as well as my extra help. So I told you I would give you at least 3, so I've already done 1 retake opportunity. This one is on Wednesday, and the following one, the last one, will be the last week of the quarter after you've had your Chapter 3 test. Tomorrow I will finish writing up there so that you can see the rest of the chapter. Chapter 3 is really quick. It's only 4 sections long. So you will have an upcoming test on Chapter 3 on 10/3, October 3rd. And then after that, you just have the graphing quiz, and then that's it for the quarter. So this is upcoming events. You will get your tests back at the end of the period. If you have questions, please feel free to come by during lunch and ask me. I tried to circle things. When you get your paper back, depending on the forms you had, the question that was focus and directrix asked you to ultimately write the final answer in standard form. So I worked around and I looked at people's work and all that stuff. If you wrote it to me in vertex form correctly, I gave you points. If you wrote it to me in standard form correctly, I gave you an extra half of a question back. So instead of a 110, somebody, actually a bunch of somebodies during the course of the day ended up with 114 because not only did they do what I asked, they went above and beyond. So they included that because that was like a 2-stepper. That's the way the county is going to do it. They're going to ask you multiple standards in one question. Okay? So today we start in with polynomials. We finished the biggest chapter of the year, which was the quadratics. Now we're in with polynomials. So many different types of your binomials, trinomials, etc. We have quadratics, we have cubics, we'll have quartics, we'll have quintics, and again, they might be 2 values long, 3 values long, etc. We're going to talk about max and min, which you should find really easy, and I'll reference problems on your homework that would be great test questions. But before I get started, on number 9, when I typed that up, I forgot to put the directions on it. So I typed up the story, but forgot to do this part. So you need to write in on number 9 on your homework, write the function to represent the volume of each box the company makes. So that's on your number 9 on your homework. Everybody should be writing this down. And that question would be a great test question. We'll look at one like that later in this lesson. Anybody still writing the directions down? Just go here, you might see better. Okay, so I'm starting with the basic. We've already had this on our graphing parent function worksheet. This is the graph of x cubed, values that you know from x cubed. 0, 0, 1, 1, 2, 8. How did I get 8? 2, 8. The point is 2, 8. How did I get that? Yeah, you cube 2. 2 times 2 times 2 is 8. And then at the other end, -1, -1, and -2, -8. Those are always values on your standard cube that is your parent. Now, on your test, I will also ask you about end behavior. So I'm putting it from the beginning of the chapter to make sure you're amazing at it. So this says, as x goes to infinity, as we're going to the right, the f of x is going to infinity. Does that make sense? It's going up. And as x goes to negative infinity, as we go to the left, f of x is heading down to negative infinity. Have you seen this before? Yes, it was already on your parent function worksheet. So this you should know by heart, but any of these that I throw at you, you should be able to give me end behavior, and that should be, oh, that's an easy question kind of thing. So what we're going to look at today is the different types of x cubed equations you could have, because this is just the parent, and this one only hit the x-axis in one spot. Absolutely, yeah. Okay, now, this is more of a visual, so just look at what I have up here for you. It says 3 linear functions multiplied together. So I gave you an example. Wouldn't x to the 1, wouldn't that make a line? Y equals x. So x times x times x, like base, you add your exponents, gives you an x cubed. So if I multiplied a line times a line times a line, I would actually get a third degree equation. I also wrote to you a linear times a quadratic, a line times an x squared, x to the 1 times x to the 2, would also give you an x cubed. And then I made you a little picture showing you what would happen if I graphed a line and a quadratic, and I said, now I want you to multiply those two equations together. My end graph would actually look like a third degree equation, okay? Multiplying the two functions together. Now, look at this. Whether you look at the function in algebraic terms or you look at the graph, how many times did my cube hit the x-axis? 3 different places, right? 3 distinct places. Where does it hit? Tell me.
-3, +1, and +4.
Perfect. -3, +1, and +4. You could tell 2 ways. You could tell by setting each of your quantities and setting them equal to 0 and solve for x, or you could literally read it right off the graph. So this is something that has 3x intercepts third degree equation. So the degree tells me the most amount of intercepts I could have. I will not have more than 3 answers, but I could have less than that, okay? So that was a nice third degree equation. If I had to graph this, in order to see how high and how low to make it go, like the peaks and the valleys, the hills, the valleys, you would have to keep plugging in numbers that fall between the -3 and the 1 and between the 1 and the 4, so you could make your graph and see how it actually flows. Mm-hmm.
So basically, this is like you're steering multiple parabolas.
Yeah, but they're not always symmetric. So parabolas have all these rules with symmetry. These don't necessarily have rules of symmetry. Okay, here's my next one. It says, now, what would we expect with this function? F of x equals x plus 3 times x minus 1 times x minus 1. Do you see x minus 1 there twice? So could I write it as quantity x minus 1 squared? Could you abbreviate that? So you can see on my picture that my graph hits at -3, and my graph also hits at 1. Oh, it only hits in 2 places. X equals 1, from this right here, is referred to as a double root or a multiplicity of 2. I get that value from the square. So if this right there, where I'm pointing at the square, if that had been a 4, then I would have said multiplicity of 4. If this square right here would have been a 7, I would have said a multiplicity of 7, okay? How many times the same answer is there? So when you graph this, we would be saying, oh, well, it kind of bounces off of where x equals 1, and then it pops back up again. That's what it's doing with the double root. Now check this one out. This one is really just a shift. I put this here down below with the A, B, C, D because I wanted you to see from what we did in quadratics how I'm just taking my picture and see how this says x minus 1 cubed. The minus 1 is inside the parentheses. That means 1 unit to the right. So I took my parent, the x cubed, and moved it 1 unit to the right. Check this out. Look where that point is. So instead of going through 0, 0, now it goes through 1, 0. We shoved everything over 1 unit. So this one, x minus 1, x minus 1, x minus 1, or x minus 1 cubed, hits the x-axis at 1, and it has a multiplicity of 3 because of the cube, exactly. Question?
How exactly would you plug in the values into
You would
times b?
here, oh, there's no A to worry about, there's no B to worry about, only the C, and there's no D. So all this had is, so this is like there's a 1 out in front, there's a 1 taken for granted in front of the X, and there's a 0 hanging out at the end. So the only thing you had to worry about on that one was I shifted it 1 unit to the right. Okay, ooh, this one looks more intimidating. So it says, we could also be tricked, if not careful, and think that there's a multiplicity of 3 when actually there might be 1 real and 2 imaginary. So this one is going through 1 and then going through -1 on the y-axis. This comes from the equation x plus I, x minus I. So if I set both of these guys equal to 0, would you agree I would get the answer -I and +I? And then the third one gives me the 1. So there's only 1 real root on this one. The other 2 are imaginary. And this I would know by looking at the equation, but I wanted you to know that this could happen, that it's not always a multiplicity of 3. And here's your hint right here. What do you remember about imaginaries as well? Was it a surprise that there were 2 I answers? I's always come in pairs. Good. Okay, I like this topic. So, max and mins, you just have to understand the difference between relative and absolute. So before I even start talking, which word do you think is more detailed, the word relative or the word absolute? Absolute is more specific, more detailed. So we're going to look at this, and I write this down, whether you just look at it and you get it, or you need to write down the definition, that's up to you. I absolutely put this on the test, where given a graph, I will ask you to give me the coordinates of the relative max, relative min, absolute max, absolute min. So make sure you can do that, and I consider it an easy question because if you understand the definitions of these and you can read a graph, then it's easy, okay? And by now I think everybody can read points on a plane. And I'll scoot it down in a sec. So I wrote to you, relative max is the highest point in a particular section of a graph. The section doesn't mean quadrant 1 versus quadrant 2, et cetera. That came up last hour. So anything that is a low point, we're going to call it the relative min. Anything that's a high point is a relative max. But absolute max is the highest in the entire graph. And absolute min is the lowest point on the entire graph. So we'll fill in a sec what we think each is to make sure you're good, and then I have 2 more examples like it. Okay, so as you're finishing up, I'm looking at my picture. My absolute min is as low as it can go. Do you notice that this is a set interval? It runs from x is a little bit less than -4 to x is about 1.5-ish. Can you see? So it's in a fixed interval. It doesn't go on and on and on forever because I have nice endpoints there. Now, I plotted 4 specific values there. Could you tell me if point 1, 2, 3, or 4 from left to right is the absolute min? Which one do you think is the absolute min? The first one, good. So this would be my absolute min, which happens at about -4, -5-ish. Okay? Now, which one do you think is my absolute max? Absolute max. The fourth one, awesome. Absolute max. It's as high as it can go. Do I need to write down coordinates for anybody? No, good, okay. Then the other two, so this point right here must be, it's a max because it goes up, and it is considered a relative max. It is a high point in an area, in a region. And this right here is a relative min, and there can be more than one relative max and min. And it could be a graph where it just keeps going and going, kind of like a snake, up and down, up and down, up and down, and you could have a lot of points. Now, this came up in another class, so I thought I'd talk about it. I did some research on it many years ago. They wanted to know if, in addition to calling this my absolute min, you have to say that, if I could also call this a relative min. Yeah, it is a low point in a region. It's also a special one. So if you were listing your relative min, and not only did you include this one, but you also include that one, you would get it right, as long as you didn't mess up with the absolute. Okay? So I understood the question, and actually the mathematicians, when you started researching it, came up with different decisions, but I went with the majority. Okay, so here is another visual. So I have 1, 2, 3, 4, 5, 6 points. I want to know, I want a female to tell me the absolute max. Absolute max, you don't have to give me the coordinate, just which point is it? Okay, the one at the top. So this is the absolute max because it's as tall as it can go. So I want you to feel like that, like you're looking at like Mrs. Stewart. Of course that's the absolute max because it's the top one. That's how you should feel when you're showing somebody as well. Okay, now, what about the absolute min? The third one, good. Absolute min. Okay, so then everything else has the name relative. Would you agree with me there? Since this is a low point, it's relative min. This is also a relative min, yes? This is going to be a relative max. And this is going to be a relative max. Question? So on your test, I'll give you a picture, and then I will say A, B, C, D within that one question. Give me the coordinates for the relative max, the relative min, the absolute max, the absolute min. Okay, A, B, C, D. So make sure you can do that. Do you need a second example? Does anybody need another example? No? Okay, I'll keep going. Okay, so this is from your textbook, page 219, 220. Some teachers I know skip over this. I want you to practice your expanding. They skip over it because they assume you're really good at it, and I assume otherwise. So this question right here actually comes from a word problem, but I wanted you to see the expansion. So I wrote to you that you can do this method that I'm going to run through with you right quick, or you can do the table method. Whichever way you learn to FOIL and distribute is fine with me. I'm just making sure that that standard from algebra is still upstairs, so we're going to practice. So in this problem right here, I had you, it says the height times 18 minus twice the height times 12 minus twice the height. It was a story where we took a flat piece of paper and we folded up an edge and folded up an edge, and now all of a sudden I had like a little box to be able to fit things in. But I needed to write this in expanded form. So what I chose to do was FOIL this first, and then after I FOILed that, I distributed the H in and simplified, okay? So that was the process I went through. I'm going to do one with you step by step here. So I'm going to do this one right here. The first thing I would do personally is I would flip-flop 1 plus 2x, and you don't have to. I just like the look of it better when it says 2x plus 1. So when you have three values like this, you want to FOIL a set of them, and then take that answer, usually a trinomial, and multiply it by the third value. Heads need to be up, please. Okay, so we're going to deal with these first. Here we go. X times negative 3x is negative 3x squared plus 2x minus 6x plus 4. Questions so far? Good old-fashioned FOIL. Okay, consolidate like terms. Am I done? No. Now bring down that 2x plus 1, and you're doing what's called double distributive. You're going to distribute in the 2x with everything, and then the 1 with everything, and combine like terms. Could you, that's what I'm going to do. Could you, if you wanted, this is a general question to all of you, could I multiply negative 3x squared times 2x plus 1, negative 4x times 2x plus 1, and then 4 times 2x plus 1? Yeah, that would also work. So you decide which you like better. You just can't mix and match. You can't change halfway through a problem. So I'm going to take 2x times all three terms. I would get negative 6x cubed minus 8x squared plus 8x. Everybody agree so far? And then I like this because when I multiply by 1, I don't have to think really hard. So 1 times negative 3x squared is negative 3x squared. 1 times negative 4x is negative 4x, and 1 times 4 is 4. And then I'm going to consolidate negative 6x cubed minus 11x squared, a 4x, and a 4. Okay, so I put some of those on your sheet because I want you to practice, because yes, I know you had it in Algebra 1, but yes, I also know some of you weren't great at it in Algebra 1. Okay, so make sure you can do an expansion. I would put 1 on your test. Now this question, before I got to even get to it, came up in last period. One of my really smart girls wanted to know if quantity x plus 2 cubed, or whatever problem I had up on the board, was the same thing as x cubed plus 8. So what she wanted to do, what she described to me was, she goes, well, I kind of just distribute the cube with the x with the 2. Okay, this quantity x plus 2 cubed means write x plus 2 out 3 times. If you just throw the cube with those two parts, then you're going to miss all the middle values, okay, which is what I showed you right here when I actually went through the math. So please, please be careful with that. I pointed to it because it is a very common wrong answer on standardized tests, on regular tests, etc.
So if you distribute it, it's equal. You would distribute. I mean, if you FOIL the x plus 2.
You're going to FOIL this, and then after you do that, so I wrote it out here, after you get the answer to this, which is x squared plus 4x plus 4, you multiply it by x plus 2, then you get this nice long answer there.
So that's correct.
That's correct, yeah. Okay, here is my story problem. I've got 2 of them. So we have a geometry teacher, and she distributes sheets of construction paper to her class. This is on my sheet, but this is a great test question. What does that mean? Listen carefully, and you'll see examples of this on the study guide when you get it tomorrow. So that they can create open nets of rectangular prisms. She instructs her students to cut squares from each of the 4 corners. So here's my visual. and this is not drawn to scale. Okay, so she wants me to cut out on the 4 corners so that basically I can fold it and make a nice looking box, okay, an open box. And it says, and then fold up the remaining sides to form a box without a lid. Each sheet of construction paper is 24 inches long, so we've got 24 right here for the whole thing. And it's also 18 inches wide. That's this whole thing is 18. Now, when I go back and I cut out the height, it says let's let X represent the side length. So the side length is this. But if this is X, would you agree so is that? It's an X by X. So that you don't have like one side up higher than the other. Now, when you take this and you fold it up, do you know what that becomes? Think about your 3 dimensions of something for volume. Would it be a length, a width, or a height? A height, yeah. So you actually know your height is X. So I'm going to fill this in right quick for you so you can see that. Now, I'm going to be writing a volume equation, V of X equals, and I already know my height is X because I'm folding it up that much. Now, when I fold it up, does that mean that this width that was here becomes shorter? So both your 18 and your 24 is going to be affected when we fold it up. I'm going to lose X on the right side, and I'm losing X on the left side. So how much am I losing? 2 X's, good. So that means this becomes 24 minus 2X. Does that make sense? Okay, so then that's my next dimension. And then the 18, we started with 18, and we folded up X, and we folded up X. So how much are you left with? 18 minus the 2X, because you're losing 1X and 1X. So then your other dimension is 18 minus 2X. And it said write an equation. It didn't say solve it. It didn't say do anything else with it. It just said derive an equation. Done. Mm-hmm. Absolutely. And when you get the study guide tomorrow, like I said, you're going to see one similar to this, as well as the next one that I'm going to do with you. Okay, anybody still doing pictures? Good. Okay, last one. Okay, this one says a company makes different sizes of boxes. The widest box has a width of 27, a depth of 10, and a height of 8. So I'm filling in on my picture. Did I do one like this on your paper? Is there one similar on your worksheet? Yeah, I thought so. Now, other boxes the company makes decreases in width by increments of 3. So let's see what that means. They either make widths of 27 or 24 or 21 or 18 or 15. What am I doing each time? Taking away 3. So the width could be 27, or I could take away 3 each time, but I could take it away, like I can make a really tiny width. So there's the X, and you can use any variable you want. I choose to use X, especially since the multiple choice used X. Now, the next, it continues, it talks about the depth and the height. For each decrease of 3 that I just took care of, it says that both D and H increase by 1. So the depth, which was 10, increases by 1. Do I just write 1? 1x, okay. And the height that was 8 increases by 1. Do I just write 1? No, 1x. And the 1 I know is taken for granted, but I'm making a point of saying that because I've seen people just put the plus 1. Okay, so now look at my sentence. It matches with one of these, A, B, C, D. D, very good. Now, one of my super smart people in last period answered A because he went right for, he saw a 27, a 10, and an 8. So be cautious when you're looking. Make sure your answer makes sense. Am I really going to multiply 27 times the X? No, that would make the box really, really big with all those increments. So your homework is the worksheet that I gave you today. And then tomorrow I'm giving you the study guide. Tomorrow I will give you the entire skills practice for the rest of the year because they came in and we'll be using that throughout. Your upcoming test is on 10/3. That's what you're working towards. And again, Wednesday is extra help after school. Wednesday is the second of the 3 retake opportunities after school. So I'm going to save this, and then after I'm done saving, I'm going to call your name and give you back your test papers.